lot to cover. Just a quick agenda, a quick review. I'm not going to review per se, but just go over where we are in the curriculum. And there's plenty of time to catch up if you're just coming to join us in the Python Introduction to Python. The two main topics that we'll cover today are branching and Python indices. And then I'll sort of finish up with how you can access the code and exercises for these sessions. Pretty much bulk of the time will be going over code, okay? Because we want to kind of get into the habit of looking at code and thinking in terms of code. Okay, so curriculum, 4 sort of big ideas that we want to cover in the introduction, and they really span the core concepts of programming, really just about any language, but Python in particular. So first big idea is the idea of program flow. And what we mean by that is program is a series of instructions, and we can give the instructions one at a time in linear fashion. However, most programming tasks require us to go beyond that. And what we looked at last time was the idea of iteration, where we have a block of code. And what I mean by a block of code is we have a set of statements that we want to repeat, and we want to repeat it over and over again. So that's the concept of iteration. And that's a central part of program, also called control flow. Tonight, we'll look at another type of program flow or control flow, and that's called branching. So we're going to cover the third type of program or control flow. Then another concept you've started to get familiar with is the concept of a variable. It can get a little bit tricky at times, but the basic concept is pretty straightforward. Think of some container, which is the memory on your computer, and a variable is just a tag or a name that we associate with some place in memory. So that's the basic concept. Then we get to the critical part of computation, and how do we think about computation? We have a set of objects, also we'll call it data, and then we perform operations on that data. And so that's the central idea of computation. And in the beginning, these are the building blocks. What you really need to get familiar with there are 8 data types, 8 objects that you need to become really familiar with. 4 of them are called primitive objects. Those are integer and float, which are numerical objects. And you're familiar with that from elementary school, decimal numbers and non-decimal numbers. Then there's character as a primitive object, string, which is a sequence of characters. And then we saw this peculiar primitive object called Boolean. There are only 2 possible values for Boolean, true and false. And then we looked at I think it was last week or the week before that, collections. So we think of primitive objects as atoms, and then collections are molecules. And this is where we really get it to what we call data structures, data that's compounded. And there are 4 basic types of collections in Python: a list, a tuple, a set, and a dictionary. And something that you'll come across and will reinforce is collections can be either ordered or unordered. And lists and tuples are examples of ordered collections. And then unordered collections are set and dictionary. And we're going to go over that because the idea of an index is intimately linked to this idea of order. Okay, and then next week we're going to look at the 4th big concept, and that's called functions. So how to define your own functions, how to create your own functions. Python also comes with a set of functions that you can use in the standard library. And then there are a whole bunch of functions that other people have written and make available to you And the way we do that is to use something called import. All right, so those are the four big ideas. Today, we're going to look at branching, which is one of ways of controlling program flow. So instead of writing a program that just goes one step at a time in a linear fashion, we're going to use branching. And the second idea we're going to go over today is indexing. And I don't have that in the representation here, but it's tied to first this idea of collections. Whenever we have an ordered collection, more generally the idea of a sequence that has order. And a string, even though it's a primitive object, is a sequence of characters, and that has an order. So the word ABA is different than BAA, even though they're composed of the same set of characters. Okay, so that's a quick recap of where we are. I want to call your attention to the basic website, and it's pythonfab.com. And this will it's really your one place to go to for the curriculum. This breaks it down into a set of learning objectives. I'm not going to repeat that. You can look at that on your own time. All the sessions will be edited and then appears on a playlist. So you can just link to that. So if you miss one or you just want to go through the session just to reinforce the concepts, they're all available on YouTube in the playlist. There's a schedule. And then something which I'll put up tomorrow is a link to the GitHub repository, which will have all the code that you can kind of look at and review. And I really encourage you to do that, to practice with the code. And I'll go over that at the end of the session and make sure that the link is there from the website so you can get to it easily. All right, so let's get started with the actual code work. So we're going to start with branching. And what's branching? The basic idea of branching is we perform a set of actions in the programming world, in the programming context. We're going to execute a block of code based on some condition. All right. And if the condition is true, we're going to go one way. If the condition is false, we're going to go another way. Well, that's a binary decision, but you can have multiple pathways and a multiple decision. And we'll get into an example of that. But from the world that we're familiar with, we do this all the time. A good intuitive example of branching is when you approach a stoplight or a signal light. If it's red, you're supposed to stop. If it's green, you can continue. And if it's yellow, you need to slow down. So based on the condition and the state of that condition, you're going to perform or should perform a different action. And that's the idea of branching. And in Python and in programming languages in general, a typical way of doing that is to use what's called an if statement. And accompanying that is also an else statement. So the general syntax is going to be, this is not actual code, but kind of pseudocode. You'll have an if statement. Then you're going to specify the condition. When the condition is evaluated by the Python interpreter, if the condition is true, then you'll perform some statement. I'm going to call it statement 1. And there typically will also be multiple statements. And that's what we mean by a block of code. Notice that the statements are indented. And so we're going to treat that, and the Python interpreter will treat that as a block of code. So if the condition is true, we're going to execute all of the statements that are below and indented below the if statement. All right, so let's take an example of that and see how that works. So first I'm going to define a variable, for temperature. So I've just written a comment statement for just annotation purposes. And we're going to write an if statement, and we're going to specify a condition. Sorry, let me first create a variable called temperature, and we're going to set the temperature at 77 degrees. So that's approximately what, 25 degrees Celsius. All right, so suppose temperature is 77 degrees. And now we're going to check if the temperature is greater than 86 Fahrenheit. Well, why might we want to do that? You'll get the idea in just a second. So we're going to specify a condition. If temperature is greater than 86, so we're going to evaluate that expression of that condition. If the condition is true, if temperature is greater than 86, then we're going to print, geez, it's a hot day. Okay, so if the condition is true, we will print, notice that the statement following the condition is indented. All right, and that's the block of code. In this case, we only have one statement that we will execute. All right, so that's the entirety of my program for now. Let's go ahead and save this Command S in a Macintosh, probably Control S on a Windows machine, and then let's run this program. Oh, okay, well, let's see. Did it print anything? Let me clear this. Okay, yeah, so it actually, it's working. And so let's just kind of go through the logic. If temperature, we set the temperature at 77. If the temperature is greater than 86, then it should print, geez, it's a hot day. But the temperature is not greater than 86, so it goes on to the next statement, and there is no next statement, so the program ends. So let's change the temperature to 90 degrees and run it again. And now we see down below in terminal, geez, it's a hot day. All right, so now we're going to add one more thing. We'll change the temperature back to 77 because we want some message. If the temperature is 77, we don't want just there to be a blank, so we'll say else if the condition is not true, otherwise it's not too hot today. Okay, so let's just look at this again. We've set the temperature up here, but the branching occurs here. We start with an if statement, specify a condition. We're going to test to see if some condition is true. If it's true, we'll print this statement, geez, it's a hot day. Otherwise, if the condition is not true, then it will print, it's not too hot today. Okay, so now let's run our modified program, and it says it's not too hot today. And let's change the temperature to 90 and run the program again. So we have, geez, it's a hot day. All right, so that's example one, where we're using the if statement, optional else statement if you want a sort of a binary thing. If it's true, then do this or go down this path. If it's otherwise else, go down this other path. Okay, now let's do another example. I'm just going to copy this and paste it. I'm going to open up branch example 2. And let's take out some of the comments so we're not verbose, so we can read it better. Now I'm going to add one more thing. Suppose you want sort of 3 pathways, similar to coming to a traffic stop. It's not just green or red, but yellow. All right, so how do we do that? Well, so let's say if temperature is greater than 86, we're going to type, it's a hot day, take out the G's. And then we're going to insert something called else if temperature is greater than 50, it's a pleasant day. It's not too hot today. Okay, so let me clear the terminal window and run this program. And so it says it's a pleasant day, 77 degrees. If I change it to 32, say it's not too hot today. Now that may not be quite right. What we might want to say is it's a cool day. Okay, so what's the logic here? If it's greater than 86, of course, these are all things that you can set yourself depending on what you want the conditions to be. But we're saying, okay, if it's over 86 Fahrenheit, we're going to print out it's a hot day. Elif, if it's greater than 50, that's the next statement that it comes to. So we already know that it's not greater than 86. If it's greater than 86, then it will print it's a hot day and then step out of the entire elif else construction. It's not gonna check the other two conditions. It's just gonna check that condition. If it's true, it will go on to the next statement. And let me just to say I am done. So let's do that. 90 here. Let's run this. So it says it's a hot day and I'm done. Okay, now if the temperature is not greater than 86, we'll go to the next statement in the construction, which is else if temperature is greater than 50. All right, so let's go back to our 77. Let me clear the terminal window again, rerun this program. And now it says it's a pleasant day, and then steps out of that entire construction and says, I am done. And then finally, suppose we have 32 degrees. Let's make it colder. So it's a cool day and I'm done. Okay. All right. So the idea here was if it's greater than 80, we're partitioning temperature into 3 buckets: greater than 86, between greater than 50 and less than 86, and then less than or equal to 50. All right. And so you're also able to, rather than using greater, you can say greater than or equal to. And if it's exactly 86, then it will be a hot day. If I didn't have the equal sign, then it would be between 50, and it will be a pleasant day. All right, so this is branching where I have 3 possible paths. Now you can have as many paths as you want, and so let's modify. Let's go to example 3. I'm just going to cut or copy this. All right, so if we want multiple pathways, I'm going to add another elif statement. Okay, so here we have 4 possibilities: greater than 86, between 50 and 86, less than 50 and greater than 32, and then below or equal to 32. And let's just test that out. I won't go through all of it, but all the possibilities. So 15, it's a very cold day. And let's do 35. And it's a cold day, and I'm done. So you get the idea. All right, now I'm going to make one more change. Again, let's cut and paste this. Now, typically, you're going to have not just one statement, but a code block, multiple statements. When some condition is true, you're going to have multiple statements. So let's just kind of illustrate that. So suppose we're making a recommendation on what to wear based on the temperature. So if it's a hot day, we might say print it's a hot day, but then say wear light clothing and sunscreen. And if it's a pleasant day, a light jacket may be a good choice. And if it's a cold day, you might want to wear a sweater. And then finally, if it's a very cold day, bundle up with a heavy coat, hat, and gloves. All right, so let me save this and then try this out. Okay, so let me clear the screen so you can see it better. Temperature is 35. Let's run the program. So it's a cold day, you might want to wear a sweater. Let's change the temperature to 15. It's a very cold day, bundle up with a heavy coat, hat, and gloves. Okay, so what have we done here? We have this construction of, depending on the condition, we're going to go in a particular direction. Here we have 4 branches, greater than 86, between 50 and 86, between 32 and 50, and then below 32. All right, so that's example 4. Now let's just modify this slightly. I won't start a new program, but what we're going to do is, rather than our providing a temperature, we'll ask some user to provide the temperature to us. So in Python, we're going to use the input statement, and the input statement requires, or it's not required, but it's a good idea to prompt the user. So enter the temperature in Fahrenheit. So suppose you were creating a recommendation on what to wear, and you're going to input from, let's say, the user, the temperature today. And whatever is provided as input will be stored in the variable temperature, and then we'll evaluate the condition to make the recommendation. Now, we're going to get an error, and I'm going to explain the error in just a minute, but let's just go ahead and save this and then run it. So as you can see below, it's waiting. It says enter the temperature in Fahrenheit, and let me enter 70, and it gives me an error. And the reason why we're getting an error is the input statement, it's a type error. It says, okay, you got an error, but greater than, not supported between instances of string and integer. So what's going on here? Remember, data in Python all have data types, and when you're performing some operation on data, the operation has to match the data type that you're working on. Now, what happens in an input statement is when somebody provides an input, let me clear this, add a space here just for readability. Let me kind of go through this again. We'll get the error again, but we want to understand why, and then we'll modify the program to adjust it. So let me run this program again. So we get a prompt, enter the temperature in Fahrenheit, and I'm going to type 77 and then return, and it gives me this error. Okay, why is that happening? When I use the input statement, whatever I type in is parsed by Python as a string. Okay, and when we perform an operate here, so temperature has the data type of string, and we're taking the string 77 and comparing it to an integer 86. And Python doesn't like that because it's a mismatch of data types. You can't compare a string to an integer. So what we're going to do is we're going to cast the data type of the input and turn it into a float. Okay, so I can turn it into an integer, but let's just go with float. If for some reason the input is somebody puts in a decimal, this will be okay. All right, so we're going to convert the input from a string to a float. If they type in something that can't be converted, like alpha abracadabra, then your program won't work. But let's say, well, now let's try this. So we're casting the data type from a string to a float, and the temperature should be okay, and then we'll compare numeric to numeric. So let's let me clear this and rerun the program. Type 32, and now it works okay. So it's a very cold day, bundle up with a heavy coat, hat and gloves. Okay, so we've done an input. Now I'm going to kind of take you one step further and write a function that does this. And we haven't gotten to functions yet, but this is a kind of a peek ahead. You don't want to have to, you're going to find in many instances where you want to reuse code that you've written multiple times, several times within a larger program. And so that's for reusability of code and also modularization that you can make code available to others, we write functions. Now, I'm not going to go into how to do a function today, but I will write the function as kind of just to get your juices going for next week. So now we're going to write a function. We're going to turn this into a function, and I'll show you how you can use it. So let me just copy this. Let's do a branching example 6. So we're going to write a function, and we're going to call the function recommend clothing. It won't take any arguments, but this is how we define a function. If you're going to write your own function, we start with the keyword def, give the function a name, parentheses, and when we study functions, you can have one or more arguments, just like in mathematics, inputs to the function, colon sign, and then return, and then now you write your function, the code block for the function, and it will be indented. So here I'm just going to repeat all the code that we did before. Now, one thing I have to be careful about is all this stuff has to be indented properly. There are quicker ways of doing this. Okay, so I've written a function, and the function just encapsulates or packages up everything that I've done. And so what does the function do? When you run the function, first you write the function, and then we'll see how then you call the function. We're going to do that in just a second. But all I've done is wrapped all of our statements, essentially 2 statements. One is we input the temperature from the user and then apply this set of conditions or branching. And then based on the condition, we'll print out 2 different statements. All right. Now, if I were to just run it as it is, it says, okay, no errors, but it doesn't do anything. So what I have to do is I have to call the function. And the way I do that is after I've written the function, I'm going to call the function. The way you call the function is do recommend clothing and provide any inputs if there were inputs into the function. But we don't have any inputs, so I'm just going to call the function. And now let's run the program. So now it's saying, okay, enter the temperature in Fahrenheit. Let's say 45. Whoops, I need to do it down below. And so it's a cold day, you might want to wear a sweater. Okay, so that is branching. And let's now jump to the next topic, which is indices. All right, so let me just kind of show you a diagram. Okay, the way to think about indices is, let's take a step back. We introduced the idea of collections. And there are 4 basic collections in Python: lists, tuples, sets, and dictionaries. And one basic property of collections are going to be either ordered or unordered. Okay, and lists and tuples are examples of ordered collections, and sets and dictionaries are unordered collections. Well, what does that really mean? It's pretty simple. The way I think about a unordered collection is, think of a sack of marbles. If you have a bag of marbles, it's a collection. It's a collection of marbles. but they're not. There's no order. There's no idea of one marble is before the next one or after some other one, right? It's just an unordered collection of objects. A example of an ordered collection is a line. When you're in a line for buying a ticket, you want to buy a Taylor Swift or going to a Taylor Swift concert, you want to buy a ticket, good luck. But let's suppose that there's a place where you can go to stand in line to buy a ticket, and there's a first person in line, there's a second person in line, and so on. So that's an ordered collection. There's this idea of somebody before you and somebody after you. And the index indicates the position of an element in the collection. Now, we could typically start with the number 1 as the first element in the collection, and this number 2 would have index 2. So the index indicates the position of some element in a collection. But in Python and in a number of other languages as well, we start the index at 0, not at 1. So the first item in the collection, the first element in the collection, is at position 0. And the second one has position 1, and so on. All right. Now, so ordered collections have each element in the collection has a position. Its position is indicated by its index. And that allows us to retrieve individual elements from a collection based on its index value. And we'll see that in operation. Okay, so think about unordered collections and ordered collections. Not to confuse matters, but the idea of indices and order, there's a more general term. It applies not just to collections, but any sequence. Okay, a sequence can be ordered or unordered. And a string, while it's not a collection, string, remember, is a primitive object, is a ordered sequence. So this idea of index, each character in a string has an index value. The first letter or the first character in a string has the index 0. The next one has the index 1, and so on. So kind of keep that in mind. Now let's go back to our code and let's look at this in operation. Okay, so I've gone ahead and created a list, and the list is a list of authors. So we have a list called authors, and recall from last time or the one before that, the way we create a list is we start with a square bracket. Each element in the list doesn't have to be a string. You could have a number. You could have nested lists, a list within a list. But each element is we write or create a list using square brackets, and each element in the list is separated with a comma. So I've created a list of authors. There are 5 authors or elements in this particular list separated by commas. All right, now suppose we wanted to retrieve the first author in this list. Well, how do I do that? I indicate its index. Okay, so if I want the first author in my list of authors, I say square bracket, first the name of the list, then square bracket, and then its index. And let's just assign that to first author. And let's go ahead and print that. Let's clear this, and so we can see it better. Okay, so you can see that Jane Austen, we get Jane Austen as the first author in that list. And if we want the second author, let's change this to second. So that's index 1 because Python indices begin with 0. And now I'm printing out Julio Cortázar. Okay, so that's an example of we've taken a collection and we were able to retrieve elements from that list. We can also, now there's this idea of negative indices. So let me just show you that. Suppose we want to retrieve the last author from our list of authors. Well, if I knew how long how many elements there are in the list, I can use that plus 1. But a quicker way to do it is to use negative index. So -1 picks out the last element in some collection. In this case, some list. So let me go ahead and run that, and we should get, let me clear this, save. The reason why I didn't get anything was I didn't print it out. So that will always do it. Okay, so we have Annie Arnaud as the last author. The next to the last is -2. I'm not going to bother changing the name of the variable. Let's just run that. And we get Toni Morrison as the next to the last author, index -2. All right, so we've covered indices, negative indices. An index indicates the position of some element in a collection or more generally a sequence. And now let's write a program. We're going to use the condition. We're going to use this idea of a condition and print something. And so what we're going to do is let's take our list of authors. Okay, so suppose I want to know, I have a list of authors, and suppose I wanted to know what its position is in the list. So suppose I have a long list, thousands of elements in my list, and I want to know what position it is in the list. So how would I do that? All right, so first let's ask the user for the name of an author. And so author name equals, and here we're going to use input, enter an author's name. All right, now in this case, input by default interprets what you type in as a string. So we're not going to have to worry about converting this to an integer because we want a string. All right, so what are we going to do with the author name? So first thing we're going to do is we're going to check to see if the author name is an element in my list of authors, because the user might provide me with a name of an author which is not in my list, and I need to be able to handle that condition. So let's first make sure that the name that's provided is in the list. And if it is in the list, what I'm going to do is retrieve the index. And the way I can do that is authors is my list. I use the index method and provide the author name. Okay, so just look at this construction for a second. I have a list, and if I say dot index and provide an author name, if that whatever you have between in the parentheses is in fact an element in my list, then it will retrieve and it will give me the index. So I'm going to print. Now this is a little bit fancy printing the author. Actually, let me not do that. Let me just print out author index for now. Keep it simple. And here say else, if the author that the user provided is not in my list of authors, then I'll just print out is your author is not in my list. Okay, let me clear, save, and run. Okay, so enter the author's name. Let's do Toni Morrison. Oops. Author is not defined. Okay. Here, I need to print the variable. Okay, so it comes back with the index 3. So 0, 1, 2, 3, which is the correct index. Let's run the program again and give it the name of an author which is not in the list. So let's say James Baldwin. The author is not on my list. Okay, so let me run through the logic here again. So we're putting together a number of ideas. First, I'm defining a list of authors. And the way we create a list is by square bracket, specify each element in the list. In this case, we're going to use string to represent authors. We're inserting 5 authors into our list. Okay. Then the next statement, we're asking the user to input the name of an author. And that is going to get assigned to the variable author name. Now we get to our branching. And the branch begins with the first condition in the if statement. And the condition, the thing that we're checking for is author name, the name that was provided to us by the user, is that in our list of authors? If it is, if that's true, then I will execute the next 2 statements that are in that code block underneath, following the colon. Right, so if the condition is true, if the author name provided is in my list, I will execute first this statement. And what does this statement do? It takes the list of authors and checks to see what you've provided in the parentheses, which is the author name, and retrieves the index that corresponds to that. Whatever that index is, it stores it in a variable called author index, and then we print that. That's if the condition is true. If the condition is not true, in other words, if author name is not in my list of authors, then we're going to print the author is not in my list. Okay, so that's example 4. I know a lot going on. Let's do one more example of indices. And here we're going to use this idea of iteration to extract initials from a full name. Okay, and I think I may have done this in a half-hearted way last time, but let's just kind of walk through this. So here, let me cut and paste again, authors. Okay, so I have a list of authors. Now, what I want to do is write a program that goes through my list one element at a time, extracts or computes the initials of that author. Okay, so this is the type of thing that computers can do really fast if you know how to specify the logic. So I have a list of 1,000 people in my company, and I want to get their initials. All right. So how would I do that? Well, one of the patterns for iteration is to go over a collection one element at a time and then perform a set of operations on that element. So the way we do that is to write a for loop. And okay, so let's just pause here. Again, this is a recall from the for loop example. The collection that I'm iterating over, that I'm going to go over, is specified as a second variable. So I'll be going through the author's list collection. I'm going to go to the first element, pull that out, and store that in a variable called author. So the first one is Jane Austen. Okay, what do I want to do with that element? Well, I have a string, and one of the operations that I can perform on a string is to split it. If it consists of multiple words, like a sentence, if author is a string, using the split method will break it up into words, separate words. So if I have a sentence, it will separate out every time it finds a space. It will split it up into the set of words and form a list. So it will give back, split gives me back a list. And I'm going to store that as author name parts. Okay. Then I need the first initial. This is slightly tricky the first time we kind of view it. So on your own time, I want you to go through the code and just see what's working, how it works. But the idea is going to be, this is going to retrieve. So let's take Jane Austen as an example. What I'm going to get back is Jane. Author name is going to be Jane Austen. Okay, so it will retrieve Jane Austen, split it into Jane and Austen, and put that in a list. So, and that list will have two pieces or two elements: Jane, the first, or Jane's the first name and last name. And so the first initial is going to be, so first thing I want to do is take author name parts, and the first element has index 0. That's Jane. But Jane itself is a string, and the first initial, the first letter in Jane has the index 0. Okay, so that's the first initial. And then the last initial equals author name parts. Here we want Austen. That's the second element. So that has the index 1. And we want the first letter in the string Austen. And that's, again, 0. So this should give us the first and last initial. All right. And let's see if that works. Print. I'll keep my fingers crossed. Save this. Okay, so if we look below, we've got JA, JC, Elizabeth Bishop, EB, TM, AE. Okay, so if you didn't follow all of it, that's to be understood. Let me get rid of this. It's redundant. What I wanted to illustrate here was how we can use indices to perform various types of operation. Here was somebody gives you a programming task. I have a list of authors. It's in the form of a list. I want you to extract the initials for the authors. Well, how am I going to do that? Well, first I'm going to use a for loop to go over each element. I'm going to retrieve each element in the list one at a time. When I have the author name, I'm going to split it into the first name and last name. Now, I'm sure you're thinking of exceptions where this particular program is going to break down. Suppose I have an author that has like Jorge Luis Borges. This thing is not going to work properly. It's not going to give you the expected result for certain types of names. So you need to be able to think those through. How are you going to handle different exceptions? What assumptions am I making? But kind of set that aside. And so what we're doing here is creating a for loop, taking first element, splitting it into component parts, the words Jane and Austin, that gets stored in a list of 2 elements. Then we look at the first element, the first name, and then extract the first initial from the first name, and that's the first initial. Then we look at the second word in the list that we've extracted, the last name, and the first letter of the last name. Okay, and so we're using indices going against a list as well as a string, and then we print the result. Okay, we covered a lot. Now let me finish up by showing you where you can get the code so you can review it. The record of this session will be available in probably by Thursday. I'll try to get it sooner than that. And I'll update the website to have this link, but I just want you to see where this is. So there is a GitHub repository. It's called github.com/pythonfab. You don't have to remember all this stuff. I'll put the links to it on the website. There's a repository called Python Level 1. If you click on that, it has a set of notebooks. The notebooks that are now available are the ones that we covered in previous sessions. For example, primitive objects has the code for that. And for tonight's, we have branching, and it has the code for that. And we have indices, should have the code for the examples that we did tonight. I also have started to post exercises. These are things that you want to try on your own time. So starting off with 3 exercises, calculate the area of a rectangle. And I provided you with a little bit of scaffolding so you can, following the pound sign, you can type in the code. The second one is to ask the user to input a first name and their last name, and then what you should do is together to form the full name and then print it out, including hello. And the third exercise is to calculate the area of a circle, where you get the radius as an input from the user. One other thing, I'm using Jupyter Notebooks as a way of presenting to you the code. Now there's a way to bring the notebooks directly into VS Code, and it's a little bit tricky, and if you set the permissions incorrectly, you might mess up your environment. There's a simpler way to actually get access to the Jupyter Notebooks, and this is something that you're going to have to make a choice. I don't want to confuse matters and introduce too many environments for you. If you're not familiar with Jupyter Notebooks, you might want to hold off on it. But if you're willing to learn about Jupyter Notebooks, and you need to do this for data science and machine learning anyway, what I encourage you to do is to, if you want to install it on your own machine, there's an environment called Anaconda. I'll have videos for that in data science and machine learning track. However, if you don't want to install stuff on your machine, there's something called Google Colab, and it's very easy to get to. It's free. Just Google Colab. Click on Welcome to Colaboratory. Now, to use it, you need a Google account, and just log into it using your Google account. It's free. You don't have to pay for anything. So I've logged in with my Google account. I'm in Google Colab. You can start to create a notebook, a Jupyter Notebook in Google Colab like this, and do Python 2+2. You're going to hit Shift Return to execute that code. All right. Now, that's interesting, but what we want to do is if you want to retrieve all the notebooks in the GitHub repository that I showed you, you'll say Open Notebook in Google Colab, click GitHub, and then enter the path of the... Now I'm going to put all this stuff in the website so that you don't have to remember this, but I just want to walk you through what I'm doing. So here's the URL for the GitHub repository, and let me copy the path. And when I'm in Google Colab, I just have to specify the path here of the GitHub repository, hit return, and then it shows me the notebooks. And so one of the ones that we did tonight on branching, if I click on the notebook, it will pull up the notebook for you. And then you can run the code here, make modifications. So if I click on the arrow, it will execute the code. Might take a little bit. Yeah, so it says it's not too hot today. It's not going to do anybody any harm. You can modify the code, practice the code, try different things. So this could be your practice notebook. All right. So I for those of you who don't want to get into Jupyter Notebooks, it's okay. I just wanted to let you know that all the code's available. If you just want to view it, that's an alternative as well. Just go to the GitHub website, click on the notebook, such as branching, and it has the code. If you feel more comfortable, you can just copy and paste this into VS Code and then run it there and make whatever modifications. All right, so I think we've covered all the topics for tonight. I will let you go. One other thing. Next week, I'm going to give you a little preview of the environment where we'll have lots of practice exercises, the ability to have additional video and other instructional resources. And I'll give you a little preview of that next week. So thank you for joining. And as always, if there are questions that you have, please go to the Discord community, post them there. I will also post a link to the Discord community on that main website. So this is the main website. Again, is pythonfab.com. And that will be your one-stop shop for all the resources. Thanks again. Good night, and hope to see you next week. Take care.